In this video, we will look at determining whether a relation is a function. So to be able to know if it's a function, we have to know that a relation, an x value, cannot have multiple y value. In other words, x value cannot repeat, okay? Cannot repeat. So it says here, which of the following set of ordered pairs is a function? So if you look on here, there's a 2 here, 2 goes to 1, and then 2 goes to another value of 2. I cannot have that in a function, okay? So since these two are repeating, I cannot have that. If I look for number 2, negative 2 goes to negative 1, 1 goes to 2, 3 goes to 4, and then look, the x is repeating here. So basically the value of 1 goes to 2, and 1 also goes to 5 in this relation. So therefore, it is not a function, okay? Same thing for number C. The 2 is repeating here. 2 goes to 2 and 2 goes to 4. Nope. So 1 goes to 1, 2 goes to 1. It's okay if the y repeats as long as the x doesn't repeat. 3 goes to 2 and 4 goes to 4. So this is a function because the x value, I'm just pulling out the x values here. These are just the domain, okay? It doesn't repeat. Here, if I pull out the domain, see how it repeats, okay? So that's that. When you have a graph, the way we can check if the x value is repeating or not is by doing the vertical line test, okay? The vertical line test. So basically you are going to draw vertical lines, and just if it hits it at two different spots like this, it is not a function. Same thing here, right? If I draw vertical, you can draw the vertical lines anywhere, and if it hits it right there, it is not a function. Basically the x value, negative 3, is going to two different y values, and this is also not a function. C is a function because for every x value there's only one value, okay? All right, and then when you have an ordered pair, the way you can check is for a function, you could have something like this. For not a function, missing an n. If you cannot have the same x value going to two different y values, okay? So if you see it this shape, then it's not a function. Which I see this shape here, 3 goes to 2 and 3 goes to 7. 1 goes to 2 and 1 goes to 5 there. 6 goes to 3 and 6 goes to 4. And then this one is a function because every value has its own, okay? Yep. All right, which of the following does not represent a function? So this is a function, x is not repeating. This is not a function because 36 is going to two different y values, so this is not a function. This is a function, and this is a function. All right, which ordered pair, x and y, so these x and y values, could be included so that it would remain a function of x? So basically, I'm adding another function here, another point here that would keep this a function. So if I add the answer choice A, 1, 3, this would not be a function, right? Because then the x1, the ones would be repeating, okay? So that cannot happen. Let me see, negative 1, is there a negative 1 here? No, I think it's B. Because if I put negative 1, negative 4, I don't have a negative 1, or any of the domain is not repeating. Negative 3 would repeat, negative 5 would repeat, so yeah, it's B. All right, a function of x consists of 5 ordered pairs. 4 of the ordered pairs are shown here. Which one could be added? So basically same thing as the previous one. If I put the 9, yep, it's A, because 9 is, you have 1, 3, 5, and 7. I'm only looking at the x values, and I can go ahead and put this in, and it would still remain. If I put the 5 would repeat here, the 1 would repeat here, the 3 would repeat here, so only A works. All right, thanks.